Hi everyone, welcome back to our channel. I am starting a new series which is called the MCQs Marathon, where I am going to upload all the possible solution of the MCQs that I post on community post. For a motion in a straight line with a constant acceleration, the ratio of magnitude of displacement to the distance covered is. First let me explain you what is displacement and what is distance. Let us suppose there is a point A and there is a point B. If I have to reach point A to B, there is n number of possible path. Like the possible path in 2D plane, that how I can travel to point A to point B. The shortest path between any 2 points is said to be displacement. And the length covered during the path AB is said to be distance, which means displacement is always smaller than distance. Okay, but in a particular case we can discuss that this displacement can also be regarded as distance if the distance is the minimum possible short length between 2 points A and B. That's why displacement is always smaller or equal to distance. If we divide both sides by distance, we get ratio of the magnitude of displacement to the distance covered is less than or equal to 1. That is, our correct option is option number D. The position of a particle moving on a straight line is given by x as a function of t is given as 12 plus 18 times t plus 9t square. Now, as you all know that acceleration is the first derivative of velocity with respect to time. Also, we know that velocity is the first derivative of distance covered with respect to time. That's why we can derive as acceleration is the second derivative of distance covered with respect to time. Now, if I derivative this with respect to t, we get velocity equals 0 plus 18 plus 2 times 9 multiplied by t. Now, if I again derivative it, I get 0 plus 2 multiplied by 9 multiplied by 1. That is, acceleration is meter per second square. Now, acceleration is 18 meter per second square. That is our option number 3. For the question, it is given as a particle is thrown. If this is our ground, it is thrown vertically upwards. That means with 90 degree upward. It reaches us up to a certain height h. Then at the height h equals half, that is 8 height h by 2. Our velocity at h by 2 equals 10 meter per second. Now, as we all know that at height h equals h, our velocity becomes 0 meter per second. In equation of motion, we get v square equals u square plus 2as. In such condition, the acceleration is negative of acceleration due to gravity, as we are going against the gravitational force. That's why v square, as we all know that the v square is 0 and u square is 10 square minus negative of 2 times g. Yes, if we take g equals 10 meter per second square, we get, as we all know that the displacement is h by 2, as we are going from this to this point. So 10 square equals 2 times of 10 multiplied by h divisible by 2. We get h equals 10 meter, and that's our correct option. The motion of a particle is given as s equals the function of t, that equals 3t cube plus 7t square plus 14t plus 8 meter. Then The value of acceleration of particle at times t equals 1 is, as we all know that acceleration is second derivative of distance or displacement covered with respect to time at t equals 1 second. Then if we derivative this with respect to time, we get 3 into 3t square plus 7 into 2t plus 14 times 1 plus 0 meter per second. Now acceleration is given as 3 multiplied by 3 multiplied by 2 times t plus 7 multiplied by 2 times 1 plus 0 meter per second. Now acceleration at times t equals 1 second is given as, if we just substitute the value of t as 1 here, that equals 18 plus 14, that equals 32 meter per second square. And our right option is option number B. Now, when more than 2 balls, means the minimum 3 balls are in sky, then the time of flight for the first balls should be more than 4 seconds. That means 2 times u divided by g should be greater than 4 seconds. That means u should be greater than 2 times g, that is 2 times 9.8, that equals 19.6 meter per second square, which means our option number A is the correct answer. If a ball is thrown vertically upward with the velocity of u, the distance covered during the last t seconds of its ascent is thrown vertically upward, it will take t times to reach h distance. That means v equals u negative of g times t. At topmost position, the velocity v equals 0 meter per second. That means we get as t equals u divided by g. Velocity of ball after t is v equals u negative of g times t minus t. That means we get v equals g t. If we substitute it in the value of s equals ut plus half at square, during the last t second of its ascent is s equals ut plus half at square. Let's substitute the value here. U equals g times t negative of 1 upon 2 half of gt square, where we get half of gt square. That means our correct option is option number B. Now we are given as a ball is thrown vertically upward. It has the speed of 10 meter per second when it has reached 1/2 of its maximum height. That means it reaches h equals h by 2, the velocity u equals 10 meter per second. Now for this time interval we get s equals h by 2. Now if we substitute using equation of motion, that is v square equals u square plus 2as, in such scenario, as we are going against acceleration due to gravity, that means our acceleration will be negative of acceleration due to gravity, and our distance will be half of h. Then we get s equals 10 meter. That means the height at which our ball rise will be 10 meter. Car runs at the constant speed in a circular track of 100 meter. That means r equals 100 meter, taking 62.8 seconds for each circular tap. That means by r, that means circumference, that means we get 628 meter. One complete convolution, the net displacement is 0. That means average velocity is 0. Average Speed is the rate of change of distance with respect to time required, which mass 1 kg and B of mass 3 kg are dropped from the height of H equals 16 meter and 25 meter. For body A, H equals 16 meter, and for body B, H equals 25 meter. Then in both the case, U equals 0 meter per second. Now using equation of motion here, we get S equals ut plus half at square. In such case, we are dropping the object. That means A equals positive of G. That means I can replace A with G, and as we know that the initial velocity is 0, that means I can eradicate it, giving me S is directly proportional to T square. Now also we can conclude that T is directly proportional to under root of S. Now using for body A is to be TA is to TB is under root of 16 divided by 25, which we get 4 times. From that we get the ratio as 4:5. That means our correct option is option number A. Now we are given as the position of x of a particle with respect to time along with x-axis is given as x equals 9t square minus t cube, where x is in meter and t is in second. T is a function of second. What will be the position of particles when it reach maximum altitude? For this we need to calculate velocity. That means first derivative of x with respect to time, that is 18 times t negative of 3 times t square. At maximum speed we get acceleration or first derivative of velocity with respect to time equals 0. That means 18 subtracted by 60 equals 0. For that we simply get t equals 3 seconds. Therefore our position is, just substitute the value of t in x, we get 54 meter as position. That means option number A is our correct answer. A particle move a distance x in time t according to the equation x equals 1 upon t plus 5. Then acceleration is proportional to, this is our question, right? The basic. Let's start with what's its velocity would be. That means if I simply differentiate it, I get t equals dv by dt, dx by dt equals, that is nothing but our velocity equals negative of t plus 5 square. That means our acceleration is derivative of dt, which equals 2 divided by t plus 5 cube, which equals 2 times of x cube. That means we can conclude that acceleration is directly proportional to the distance raised to power 3. Now we do not have this type of equation here. Now we will use this equation as I. Now from I we get this is similar, like I can just substitute at velocity. Now from I we get the velocity raised to power 3 by 2, that is 1.5 equals negative of 1 divided by t plus 5 square. That is nothing but acceleration is directly proportional to velocity raised to the power 3 by 2. That means our acceleration of the particle is proportional to velocity raised to power 3 by 2. question we are given is the velocity of particle equals a times t plus b times square of t. Now, where a, b are constant, then the distance traveled by the object between 1 and 2 seconds is, as we all know that velocity is the first derivative of position or distance with respect to time. That means if we integrate, or I can simply say as dx equals a t dt plus b t square dt. That means I can calculate the displacement by integrating these all equations with respect to dt and dx. We get particle A equals, it we all know that at time t equals 1 second, our displacement x t equals 1 second equals half of a plus 1/3 of b plus c. If I simply subtract these two, I get the distance traveled by the particle in between 1 and 2 seconds. We get x equals 3 by 2 times a plus 7 by 3 times b. That means our option number A is the correct answer. Ball is thrown vertically downward. That means our initial velocity is 20 meters per second. After it hits the ground, its velocity becomes 80 meters per second. That means if we use the equation of motion as v square equals u square plus 2as, we get velocity u equals 20 meters per second. And acceleration, as we are going towards the acceleration due to gravity, that means it will be positive of z plus, and h equals h, that means plus u square. If you just simply substitute the value as 80 square equals 2 times of 10 multiplied by h plus 20 square. If we simply substitute at h equals 6400 subtracted with 400 divided by 2 times 10, we get 300 meter. That means the height of the tower from the ball is thrown is 300 meter, which is option number C. Now, as per the question, a vehicle travel the half of the distance. That means if a vehicle has gone from A to B, it traveled the half of the distance with the speed v and another half with speed 2v, then the average speed is. Now, for the average speed, we know it's the harmonic mean if the distance is the same. That means here it also h divided by 2, here it's also h divided by 2. That means it's the harmonic mean between v1 and v2. 2 times of v1 v2 divided by v1 plus v2. That means yes, average equals 2 times of v multiplied by 2v divided by v plus 2v, that is nothing but equals 4v divided by 3. Option number B. The ratio of distance traveled by a freely falling body in first, second, third and fourth second is, as we all know that if the body is freely falling, that means u equals 0 meter per second, and distance in nth second is given as, if we substitute u as 0, we get yes nth is directly proportional to 2n minus 1. If we calculate as yes first is to yes second is to yes third is to yes fourth, we get 2 times of 1 minus 1, 2 times of 2 minus 1, 2 times of 3 minus 1, 2 times of 4 minus 1, that is nothing but 1 is to 3 is to 5 is to second. Of a particle is given as r vectors is a function of time equals 4t I cap plus 2t square j cap plus 5k square 5k cap, sorry. Now the velocity is nothing but differentiation of r vector with respect to time. That is nothing but equals 4 I cap plus 4t j cap equals 4I cap plus 4j cap. Magnitude of velocity equals under root of 4 square plus 4 square, that is nothing but 4 under root 2 meter per second. Now the angle is with respect to x-axis is nothing but tan theta equals ay divided by ax, that is 4 divided by 4, that is 1. As we all know that tan theta equals 1 when the angle is 45 degrees, so the angle is 45 degree. That means our correct answer is option number A, 4 under root 2 meter per second is velocity, and the direction of velocity is 45 degrees with respect to x-axis. Given is the time t as a function of displacement, that equals x square plus x. Now if we differentiate time with respect to x, we get dt upon dx equals 2x plus 1. Now the velocity is the inverse of derivative, that is velocity equals v equals dx by dt, so it equals 1 upon 2x plus 1. Now we also need to calculate derivative with respect to x. V equals dv by dx. Now we need to calculate the rate of change of velocity with respect to x. We get minus 2 upon 2x plus 1 raised to power 2. That's a equals v multiplied by dv by dx, which equals v equals 1 upon 2x plus 1 multiplied by minus 2 upon 2x plus 1 raised to power 2. From this we get acceleration is negative of 2 divided by 2 multiples of 1, 2 multiplied by x plus 1 raised to power 3, which is our option number D. If the velocity of a body relative to displacement x is given as v equals under root of 5000 plus 24 x meter per second, then we need to calculate its derivative with respect to x, that is nothing but dv by dx equals 0 plus 24 multiplied by 1 upon under root of 5000 plus 24x, which is nothing but equals 24 divided by under root of 5000 plus 24x. Now acceleration of a body is given as v multiplied by derivative of v with respect to x, which equals under root of 5000 plus 24x multiplied by 24 divided by under root of 5000 plus 24x. Acceleration due to, now from this we get acceleration of the body as 24 meter per second square, that is the acceleration is 24 meter per second. We are given as x square equals at plus 2bt plus c, which is the motion of the particle. Now if I differentiate I with respect to t, we get 2 times of x multiplied by dx by dt, which is nothing but our velocity equals 2at plus 2b. From this we get xv equals at plus b, that means v equals at plus b divided by x. Now again I am differentiating this second with respect to time. I get x times a dash plus v square equals a, that means I am differentiating this from this. I get as this, that a dash is the acceleration and a is the constant given. So if I just solved it using the value of v square, that is x multiplied by a dash equals a minus v square, that is nothing but x times a dash equals e subtracted by at plus b raised to power x square, which is nothing but x a dash equals ax square minus at minus b square raised to power ax square. That means a dash is directly proportional to 1 upon x cube. That means the value of n is 3. Two bodies, one held 1 meter above the other directly, are released simultaneously and they fall freely undergoes after 3 seconds with what will be their relative separation. Now, the initial velocity, that is initial relative velocity equals 0 meter per second. The relative acceleration will be g subtracted by g, which is nothing but 0 meter per second square. Now the time is 3 seconds. Then the relative change in separation will be 0. So the relative separation remains unchanged as 1 meter. That means our option number B is the correct answer.